December 26, 2024. While Americans were unwrapping Christmas gifts and settling into their holiday routines, something extraordinary was happening on the other side of the world. In a remote corner of China, an aircraft unlike anything the world had ever seen was taking its first flight. No fanfare, no media coverage, just a shadowy prototype cutting through the sky with a design so radical it would send shockwaves through Pentagon war rooms. This wasn't just another fighter jet. This was China's answer to American air superiority, and it represented something far more dangerous than most people realized. A tailless stealth design that military analysts are calling the J-36. But here's what makes this story even more incredible. Just 3 months earlier, the United States had nearly killed its own next-generation fighter program. The NGAD project, America's most advanced air superiority fighter, was sitting on the chopping block. $20 billion in research and development, $300 million per aircraft. The Air Force was ready to walk away from the most expensive fighter program in history. But something changed everything. War games. Simulations that showed a terrifying reality. America's current strategy wasn't enough. The days of winning air battles with standoff weapons and legacy fighters were over. The future belonged to whoever could master the combination of stealth, artificial intelligence, and swarm tactics. So, in March 2025, the program was back. The Boeing 47 was born. And now we're witnessing the beginning of the most consequential arms race in aviation history. Two superpowers racing toward the late 2020s, each betting everything on their vision of future air combat. The question isn't who will win. The question is what the world will look like when they're done. Let's go back to late 2024. The Next Generation Air Dominance program was America's crown jewel. Years of development, cutting-edge technology, and the promise of maintaining air superiority for decades to come. Then, suddenly, everything stopped. The Air Force hit the pause button on the entire program. Not a delay, not a budget adjustment, but a complete halt while they conducted what they called a comprehensive review. Defense contractors were stunned, military analysts were baffled, and America's enemies were watching very carefully. Why would the United States voluntarily stop development of its most advanced fighter? The numbers tell the story. $20 billion, just for research and development? That's before building a single operational aircraft. When they actually started production, each 47 would cost approximately $300 million. To put that in perspective, that's more than 3 times the cost of an F-35 Lightning. The Air Force wanted 200 to 250 of these aircraft to replace the aging F-22 Raptor fleet. Simple math showed this program would consume nearly $100 billion over its lifetime. In an era of budget constraints and competing priorities, even the Pentagon had to ask the hard question, was it worth it? But then came the war games. Military planners ran scenario after scenario, testing America's current capabilities against peer adversaries. The results were sobering. Traditional standoff weapons, the backbone of American air strategy, weren't enough anymore. Advanced air defense systems, electronic warfare capabilities, and the emergence of stealth technology in adversary forces had fundamentally changed the battlefield. The simulations showed a harsh reality. Without a significant leap in air superiority capabilities, America could lose control of contested airspace. The strategic implications were enormous. So in March 2025, the program was officially greenlit. The Boeing 47 would fly. So what exactly makes the 47 worth $300 million? The answer lies in technology so advanced, it sounds like science fiction. This isn't just an evolution of existing fighter designs. This is a complete reimagining of what air superiority means in the 21st century. The most revolutionary feature is what engineers call smart skin technology. Imagine an aircraft where every surface is covered in sensors. Not just radar, but a fusion of multiple detection systems that create a 3-dimensional awareness bubble around the aircraft. The 47 doesn't just see enemies, it sees everything: electronic signatures, heat patterns, even minute changes in atmospheric pressure that might indicate stealth aircraft. This sensor-fused connectivity means the aircraft becomes a node in a vast information network. It's not fighting alone, it's fighting as part of an integrated system that shares data in real time across hundreds of platforms. When 147 detects a threat, every allied aircraft, ship, and ground station knows about it instantly. But perhaps the most game-changing aspect is the open architecture design. Unlike previous fighters that were locked into specific systems for their entire service life, the 47 can be continuously upgraded. New weapons, new sensors, new software can be integrated without massive redesigns. It's like having a smartphone that can run tomorrow's apps, not just today's. The stealth capabilities push the boundaries even further than the F-22. Advanced materials, refined shaping, and active countermeasures make this aircraft nearly invisible across multiple spectrums. But stealth is just the beginning. The real revolution comes with collaborative combat aircraft. Each 47 will operate with up to 1,000 low-cost autonomous drones. Think of them as expendable wingmen that can scout ahead, carry additional weapons, or sacrifice themselves to protect the manned aircraft. These aren't remote-controlled toys. These are artificial intelligence-powered combat systems that can make split-second decisions in the heat of battle. While America was debating whether to fund the 47, China was quietly working on their own revolutionary design. December 26, 2024, marked a pivotal moment in aviation history. The first flight of what intelligence analysts are calling the J-36 prototype wasn't announced with fanfare or press releases. It was spotted by satellite imagery and confirmed through intelligence channels. What makes this aircraft so significant isn't just that it flew, but how radically different it looks from anything we've seen before. The J-36 features a tailless design, eliminating the vertical stabilizers that have been standard on fighter aircraft for decades. This isn't just an aesthetic choice. Removing the tail reduces radar signature dramatically and allows for more efficient supersonic flight. Even more intriguing is the apparent trijet configuration. While most modern fighters use one or two engines, this Chinese prototype appears to have three. This suggests incredible power and range capabilities. 3 engines mean redundancy for long-range missions over the Pacific, and the thrust needed for sustained supersonic flight without afterburners. But here's what really has Pentagon planners concerned. This wasn't China's only prototype. Intelligence reports suggest they're simultaneously developing 2 distinct tailless stealth designs. This parallel development approach means they're hedging their bets, testing different configurations to see which performs better in real-world conditions. The timeline is what makes this a true arms race. Both the American 47 and the Chinese J-36 programs are targeting operational capability in the late 2020s. That's less than 5 years away. 5 years to go from prototype to combat-ready aircraft represents an incredibly aggressive development schedule. What's particularly striking about the Chinese approach is how it differs philosophically from American design. While the 47 emphasizes networked operations with drone wingmen, the J-36 appears focused on raw performance and range. It's built for the Pacific theater, designed to operate from mainland China and project power across vast distances to challenge American forces near Taiwan, Japan, and the Philippines. We're witnessing the birth of an entirely new form of warfare. The combination of ultra-low observable manned platforms with autonomous wingmen represents the biggest shift in air combat since the introduction of radar. This isn't just about better airplanes. This is about fundamentally changing how nations project power and control airspace. The concept of persistent kill webs transforms traditional air battles from episodic engagements into continuous operations. Instead of sending waves of aircraft for specific missions, Future air forces will maintain constant presence over contested areas. Manned fighters coordinate with hundreds of autonomous drones, creating overlapping fields of sensors and weapons that can adapt in real time to changing threats. Range and speed become critical advantages in this new paradigm. The Pacific Theater spans thousands of miles of open ocean. Traditional fighters, even with aerial refueling, struggle to maintain sustained operations at these distances. Both the F-47 and J-36 are designed to operate effectively across these vast expanses, either through extended range capabilities or by coordinating with forward-deployed autonomous systems. The speed element isn't just about getting to the fight quickly, it's about the speed of decision-making. When artificial intelligence can process threats and coordinate responses in milliseconds, the side with faster systems gains decisive advantages. Human pilots become tactical coordinators rather than individual combatants, orchestrating complex battles involving dozens of autonomous platforms. This shift creates new vulnerabilities and new opportunities. Cyber warfare becomes as important as traditional kinetic attacks. If you can disrupt the communication networks that coordinate these distributed systems, you can effectively blind and paralyze an entire air force. Electronic warfare capabilities that can jam or spoof autonomous systems become force multipliers. But the most significant change is psychological. For 70 years, air superiority has been about having better pilots in better aircraft. Now, it's becoming about having better algorithms managing better networks. The human element remains crucial, but it's evolving from direct control to strategic oversight. Fighter pilots are becoming battlefield orchestrators, conducting symphonies of autonomous systems rather than flying solo performances. The stakes of this technological arms race extend far beyond military capability. We're talking about the reshaping of global power dynamics for the next 50 years. Control of the air domain has historically determined the outcome of major conflicts, and whoever wins this race will hold decisive advantages in any future confrontation. For Taiwan, these developments represent an existential equation. The island's defense strategy has long relied on the assumption that American air power could contest Chinese attempts at invasion. If China achieves air superiority through advanced stealth fighters and autonomous swarms, that calculation changes dramatically. The J-36's apparent focus on Pacific range capabilities isn't accidental. It's specifically designed to challenge American forces operating from bases in Japan, Guam, and the Philippines. The economic implications are staggering. The United States is betting nearly $100 billion on the F-47 program. China's investment in their parallel development programs likely matches or exceeds that figure. This represents the largest peacetime military aviation expenditure in history, consuming resources that could address infrastructure, education, or healthcare needs. But there's a deeper strategic consideration. The $300 million price tag per F-47 means the United States can't afford to lose these aircraft in combat. They're so expensive that risking them becomes a strategic decision requiring the highest levels of government approval. This creates what military analysts call the golden jet problem. When your weapons are too valuable to use, they lose much of their deterrent effect. Allied integration becomes crucial but complicated. Nations that want to operate alongside American F-47s will need compatible systems and security clearances for the most advanced technologies. This creates new forms of military dependence and alliance structures. Countries may find themselves choosing between Chinese and American technological ecosystems, with lasting implications for their strategic autonomy. The proliferation question looms large. As these technologies mature, will they remain exclusive to superpowers, or will they eventually spread to smaller nations? The autonomous combat aircraft that support these fighters could potentially be developed independently by countries with significant tech industries. The late 2020s will determine air supremacy for the next 50 years. Both the 47 and J-36 programs are racing toward deployment. But this isn't just about whose aircraft flies first. It's about who can best integrate stealth fighters with autonomous swarms into a unified combat system. We're witnessing the biggest shift in air warfare since the jet age. Human pilots become battlefield orchestrators, while artificial intelligence handles split-second decisions. Victory will belong to whoever thinks faster, not just flies faster. The risks are enormous. At $300 million each, losing an F-47 becomes a strategic disaster. Meanwhile, autonomous systems introduce new vulnerabilities through cyber warfare and potential accidental escalation. When machines operate at machine speed, these technologies will reshape civilian industries too. Advanced sensors, artificial intelligence, and materials developed for these fighters will transform everything from commercial aviation to telecommunications. The critical question isn't whether these systems will deploy, but whether human leaders can control them wisely. The late 2020s aren't just bringing new fighters. They're bringing a form of warfare that could either maintain peace through technological balance or trigger conflicts through automated miscalculation. The future of air combat is arriving whether we're ready or not.